Welcome back to Daily AI News at Let's Data Science. It's 2026-05-26. Today, we're diving into some pivotal developments from the future of machine intelligence to major product launches. Let's get to it. We begin with a story that may mark a historic inflection point for AI assisted scientific discovery. OpenAI announced in a May 20th blog post that an internal OpenAI model has produced a proof disproving the planar unit distance problem, a conjecture first posed by Paul Erdős in 1946. For decades, combinatorial geometers believed that rescaled square grid constructions were essentially optimal for maximizing the number of unit distance pairs among endpoints in the plane. According to OpenAI's published materials, the model constructed an infinite family of planar point sets that achieve a polynomial improvement over that classical square grid lower bound. OpenAI released a companion paper titled Planar Point Sets with Many Unit Distances, along with a human digested document, Remarks on the Disproof of the Unit Distance Conjecture, both made available on Arxiv. The company stated that external mathematicians have checked the argument. Coverage in Nature, Phys.org, The Guardian, and New Scientist recounts a similar sequence. A chatbot style prompt, extensive model generated symbolic reasoning and calculations, and then human verification and formal write ups. Technically, the materials indicate that the construction leverages higher dimensional arithmetic analogs mapped back into planar arrangements. While the full formal verification process is still ongoing in the broader community, the result has already triggered commentary from mathematicians, including Gil Kalai, who published reactions and digest notes on his blog. From an AI systems perspective, this is one of the first widely publicized instances where a general purpose reasoning model produced a solution to a prominent 80-year-old open conjecture and where the community was able to rapidly inspect and digest the result. The key caveat remains critical. OpenAI and independent observers emphasize that model outputs are drafts requiring human verification. But the workflow, LLM-generated reasoning, human curation, Arxiv publication could become a template for future research collaboration between humans and models. For researchers and tool builders, the next phase to watch is formalization. Will interactive theorem provers or mechanized proof assistants be used to convert this argument into a fully machine-checked proof? And can similar LLM-assisted workflows scale to other long-standing open problems? The community vetting process around the Arxiv submissions will determine how this result ultimately settles into the mathematical literature. Staying with model reliability, our second top story comes from the security front. An Arxiv paper titled Chain of Thought Hijacking by Jianli Zhao, Tingchen Fu, Rylan Schaefer, Mrinank Sharma, and Fazil Berez documents a black box jailbreak attack targeting what the authors call large reasoning models. The paper, revised May 24, 2026, reports striking success rates on the HarmBench benchmark: 99% against Gemini 2.5 Pro, 94% against ChatGPT o4 Mini, 100% against Grok 3 Mini, and 94% against Claude 4 Sonnet. The mechanism is both simple and concerning. The attack induces extended benign reasoning, essentially long puzzle-solving chains of thought, before introducing a harmful instruction. Through activation probing, attention pattern analysis, and causal interventions on open-source reasoning models, the authors diagnose what they term refusal dilution. As reasoning traces lengthen, a low-dimensional refusal signal appears to weaken, reducing the model's likelihood of rejecting harmful requests. For safety engineers, this is a direct challenge to current evaluation protocols. Extended chain-of-thought prompting is widely used to boost accuracy on multi-step reasoning tasks. But according to this paper, that same mechanism can attenuate safety signals. If refusal behavior is encoded in compact internal representations, long reasoning trajectories may inadvertently suppress it. Practically, red teams will need to incorporate long, benign reasoning traces into safety stress tests. Vendors may respond by publishing mitigations specifically targeted at refusal dilution modes, and researchers will likely attempt to reproduce the reported attention and activation patterns across additional architectures. Our third top story highlights how rapidly frontier capabilities are moving from research to product. Multiple outlets, including Bleeping Computer and Testing Catalog, report that Anthropic appears to be preparing its previously restricted frontier model, Claude Mythos, for broader availability under the label Mythos 1. The model string Claude Mythos-1 preview has reportedly appeared in UI and source code strings for Claude Code and Claude Security. Bleeping Computer reports that some users briefly saw a public toggle enabling Mythos in the Claude Code interface before it was taken offline. Reporting links the Mythos preview to Anthropic's Project Glasswing initiative. According to coverage in IT Security News, early runs using the Mythos preview surfaced more than 10,000 high and critical severity zero-day vulnerabilities. Anthropic is quoted as saying, "The advantage will belong to the side that can get the most out of these tools," and warning that in the short term, attackers could benefit if releases are not handled carefully. Technically, Bleeping Computer reports that Anthropic described the Mythos preview as delivering major improvements in code reasoning and autonomy over Opus 4.7, and capable of generating professional-grade offensive code in internal testing. Testing Catalog reproduces a Project Glasswing statement indicating that Mythos class models could be made generally available in the near future once stronger safeguards are in place. For security teams and ML engineers, a general release of Mythos 1 would materially shift both defensive tooling and threat models. High-capability vulnerability discovery models can accelerate triage and patching, but the same autonomy and code synthesis power lowers the barrier for exploit generation if guardrails fail. The dual-use trade-off is explicit here, and staged enterprise rollouts with layered monitoring seem likely. Now, for a few other key updates in our lightning round. Security researchers at Eclectic IQ have identified an SEO poisoning campaign targeting developers searching for Gemini CLI and Claude Code installers. Typo-squatted domains such as geminisetup.com and claudecode.com delivered PowerShell commands using the classic IRM pipe IX pattern to execute a fileless info stealer in memory. Exfiltration reportedly included browser cookies, OAuth tokens, CI/CD credentials, and VPN keys, with traffic observed to domains like events.msft23.com. Notably, GB Hackers reports that the malicious chain installs the legitimate Gemini CLI via NPM while the info stealer runs, masking the compromise. In hardware, SK Hynix has unveiled IHBM, a high-bandwidth memory packaging solution embedding integrated cooling elements, or ICEs, inside the HBM package. According to the company's PR Newswire release and coverage by TrendForce and the Korea Times, IHBM reduces thermal resistance by 30% and is intended for next-generation products, including HBM5. The design uses wafer-level packaging and mass reflow molded underfill technology, and if validated in production, could alter thermal trade-offs in AI accelerator design. On the research front, the paper Backweak, Backdooring Knowledge Distillation Simply with Weak Triggers and Fine-Tuning, posted as ArcZiv 2511.12046, demonstrates that imperceptible weak triggers embedded into a teacher model with a very small learning rate can transfer through standard knowledge distillation into student models. The surrogate-free approach reportedly achieves high attack success rates across multiple datasets and architectures, raising supply chain concerns for teams downloading third-party teacher weights. Another ArcZiv study, Pragmatic Reasoning Improves LLM Code Generation, introduces Code RSA, a re-ranking method grounded in the Rational Speech Act framework. Evaluated on Human Evil Plus, MBPP Plus, and BigCode Bench, Code RSA achieved the strongest average accuracy in 10 of 12 model benchmark settings, suggesting that local pragmatic contests among sampled candidates may be a practical upgrade to standard code generation pipelines. And finally, the impact of large language models on open source innovation, by Doron Yevrutyahu, Ravish Maya, and Gal Estreicher-Singer, leverages GitHub Copilot's October 2021 rollout, where Python was supported but R was not, to estimate a 28 to 40% increase in contributions attributable to Copilot. The gains were concentrated in incremental, maintenance-style contributions, rather than substantive capability-extending commits, offering rare causal evidence about how LLMs reshape collaborative software development. And that's your AI briefing for today. The landscape is moving faster than ever, and we'll be here to track it with you. For more insights, visit us at letsdatascience.com. Thanks for tuning in. Stay curious, and we'll be back tomorrow with the latest in AI.